Okay, here's a short little video to hopefully help you with your homework on graphing the derivative function. So I'm going to start with C1 just because I think that's going to be slightly easier to see, and I will attach a printout that you can print out so that you can actually do an axis below each question just till you get used to these. So I've drawn an axis below. Let's just label it nicely. Of course you're going to do this with a pencil and a ruler. And the first thing to do is, after you've done that, spot where the gradient is 0. So I'm just going to highlight this in a different colour. So the gradient is 0 at the turning points. So here and here. And if we go directly below each of these points, the gradient must be 0 at -1. And similarly, if we go below 3, the gradient must be 0 there. I'm just going to get rid of those dotted lines because I think they are going to get in the way. Having said that, I've now gone and messed up the bit above, so I just have to do it from here. Okay, so that's the gradient 0. Next step, look at each section of the graph and decide if the gradient's positive or negative. So first we're going to label each section so you know which part I'm talking about. So first section is from here to -1, so A to B I'm going to call that. And then I'm going to call the next section B to C, and then C to D. Okay, so look at A to B first. I'm going to draw a tangent to the curve between A and B. So that's quite difficult because it's quite steep all the way along that section, but that orange line is a tangent to the curve. And you need to ask yourself, is that orange line a negative slope or a positive slope? Well, it's negative. So before -1, any values where x is less than -1, the gradient is negative. So it must be down here. Okay, let's look at the section B to C. And I'm going to draw a tangent to the curve there as well. So let's just draw a tangent here. And ask yourself, is that slope negative or positive? Well, it's positive. So between -1 and 3, it must be positive. So we'll draw it somewhere above the x-axis in the positive area. Okay, and as you go up here, if I draw another little tangent to the curve, and I'll do that one, that's not very clear. Let's try and draw it just here, where in fact so close to the line there, the gradient will be a maximum, and literally it's virtually on the line there. At about this point, the gradient will be maximally positive, so I'm going to draw a maximum positive gradient here. And then I'm just going to do one more in that section, just up here, where it's still positive, but it's actually getting less positive. So I'm just going to do a little cross here because it's getting less positive until it gets to 0 when x is 3. Finally, we're going to look at section C to D. What colours have we got left? Okay, let's use red and drawing another tangent to the curve there. Okay, let's say it's crossing about here. Is that gradient positive or negative? Well, it's the same as the orange, where it's a bit more negative. But important thing is that it's got to be in the negative area, so down here. So for the derivative function, for the negative gradients, you're below the x-axis, and for the positive gradients, going to be above the x-axis, and that's because the y-axis here represents the dy by dx derivative function. Right, so now we can join those points together. We should have a graph, something like that. And there is your graph of the derivative function for C1. Should really be a bit smoother. I'm getting used to this new board. Okay, so looking at B part 1, first of all doing a set of axes and then deciding where the gradient on your graph is 0, and that is at the turning point because the gradient is horizontal, that gradient is 0. That point is exactly between -5 and 3, which is -1. So the gradient at -1 is 0, and that's because this y-axis now represents your derivative function f dash x, or dy by dx, which hopefully you're beginning to get familiar, works out the gradient at any point on a graph. So now we're going to look at the gradient between the points A and B, or the section A to B. So drawing a tangent to the curve like so. What is the gradient of this line? Is it positive or negative? Well, it's negative, so you want points below the x-axis. And then drawing a tangent to the curve between B and C. The gradient is positive, so we want points above the x-axis. And remembering that's because your y-axis represents the gradient, all the y values are positive going up, and y values are negative going down, so the gradient is negative below the x-axis. And joining those points together should produce a straight line. So that's part B1. Now looking at A1, which I thought was going to be the trickiest one to explain because there are no turning points. Starting by drawing a set of axes below. So as there are no turning points, we just have to ask ourselves, what is the gradient of this line? Well, we can use our knowledge from GCSE that the gradient is rise over run. and the rise is 3. If we choose these 2 points, the rise is 3 and the run is 1. So the gradient is 3. So if we just take a few points, so if we take -1, we ask ourselves, what is the gradient of this line at -1? Well, it's 3. Take another point along the x-axis, let's say -2. Go down to the line. What is the gradient of the line at this point? Well, it's 3. So at -2 the gradient is 3. What about if we take a point down here? Let's say it's 5. Scale's all a bit off, I know, but there we are. Extending the line further up. Then ask yourself, when x is 5, what is the gradient of this line? Well, it's 3. So go here, at 5 the gradient is 3. So your derivative function for this straight line, if I use a ruler, I'll get a straight line. The derivative function is just y equals 3, because the gradient is 3 anywhere along that line. Okay, I hope that helps. We can still go through it in the lesson next time I see you.